Hello everyone, my name is Abhay Sharma, a BTech third year student, and today I am going to explain you about the experiment of speed measurement trainer using optocoupler. The speed measurement trainer allows for the study of various principles and techniques used to accurately measure the speed of moving objects. Let's take a look on the trainer. This is the speed measurement trainer, and this is the power switch. This is the power supply by which we can control the power, and it is connected to the motor and the 1 volt meter. And these are the sensors cable. Uh, this is the ground, and this two will go to optocoupler. And then we have counter. Counter counts the rotation of the disc which we are using, and this is a toggle switch which we can set to RPM if we want to see the RPM readings, and if we can set it to speed so we can see the speed of it. And these are the reset buttons to reset this count meter, and we can push this to count the number of revolutions, and we can display it on it. So what are the principle of photoelectric pickup? The photoelectric pickup uses a light sensor to detect the passage of an object and measure its speed. As the object passes through the light beam, it momentarily interrupts the beam, allowing the sensor to register its movement. By measuring the time between beam and interruptions, the speed of the object can be calculated. Let's see what is optocoupler and its functioning. The optocoupler provides optical isolation between the input and output circuits, and it converts the electrical input signal into a light signal, and then transmits it, and then converts it back to an electrical output signal. So the some applications are speed measurement, signal conversion, and electrical isolation. So let's see what is the experimental setup. So the photoelectric pickup is securely mounted on the trainer to ensure accurate and consistent measurement. So this is the pickup, and we can see it is mounted. And next is object passage. The object to be measured is passed through the beam of the photoelectric pickup, interrupting the light signal. So here you can see this one is the beam, and this is the disc. In the disc we have some teeth. When this teeth will block the beam, we then the data collection. The time between beam interruptions is recorded to calculate the speed of the moving object. So what is photoelectric pickup? The core component of trainer, it uses a light sensor to detect the passage of objects and measure their speed. Optocoupler converts the electrical signals from the photoelectric pickup into optical signals for transmission and back again, and digital displays and one mounting apparatus. Data collection and measurement. The object to be measured is passed through the photoelectric pickup's light beam. Then the photoelectric sensor detects the interruption of the light beam as the object passes through, and the time between beam interruptions is recorded to calculate the object speed. This is the total experiment setup, and now we'll watch a video to see how it is working. So this is the disc which is rotating through a motor, and this is the trainer which I explained. Here it is showing the RPM reading. This one is the wave shaper, and we can see the RMS speed and the frequency of the beam interruption, and this is the voltmeter. So we can calculate the table with the RPMs with different motor voltage and the speed counter and the time, and we can measure the speed Then the speed from the counter will be speed counter, this one, and by time, and we'll divide in multiply it with the circumference of the disk, and we will get the speed. Same we will do for the speed from RPM. And this is the graph. The graph will be between counter reading and the frequency, and the more linear the graph is, the more accurate is our experiment. So let's go to conclusion and application. There are many applications of this device in transportation, in manufacturing, research, education.